We're now going to take a look at trig function derivatives. So a little bit of background on trig function derivatives. We have our derivations for each of the different trig functions, and these are typically given to us in textbooks. So there's nothing that we really need to do to reference this, just besides writing them down. And so we'll use this to differentiate the trig function in our example problem. So for our example problem, we want to differentiate 3w to the negative 4 minus w squared multiplied by tangent of w. So the first step is we want to separate these two terms. So we have our 3w to the negative 4 on the left-hand side, and we have our w squared tangent w on the right-hand side. And we'll use different rules to differentiate these functions. So for the left-hand side, we're going to use the power rule, and for the right-hand side, we're going to use the product rule. And to give a little bit of refresher, the product rule is basically just f prime, which is the derivative of f of x, multiplied by g plus f multiplied by g prime. And so we can write down our f of x and our g of x, which is given to us in this in our terms. So we have w squared for f of x, and we have tangent x for g of x. And we can quickly do these derivations. We'll get 2w for f prime of x, and we'll get secant squared x for g prime of x. And like I said earlier, we are applying the rules that we looked at earlier to differentiate tangent x to get secant squared x. So after that, we can go ahead and simplify our expression. We'll have negative 4 multiplied by 3 times w to the negative 5 by applying the power rule. And then we'll get 2w multiplied by tangent x plus w squared multiplied by secant squared x by using the product rule. The next step is to not forget to apply this negative sign to the two different terms. And so we'll have negative 12w to the negative 5 from our first term, and then we'll get minus 2w tangent x minus w squared secant squared x for our second term. And this is the solution to our example problem.